So I'm here again to make summary with the chapter 4 network address. So the network address comes first with the physical layer protocols upon then our physical layer connection. We have the types of connection. We have the embedded wireless antenna for a home router. Then Ethernet switch. We have usually 4 Ethernet switch at the back of the home router, and another is the internet connection. Connect your computer to the Ethernet port 1, 2, 3, or 4. It is called the connecting to the wired LAN. Then we have the what we call NIC, or the wired interface card. Wired connection using an Ethernet NIC. Connecting to the wireless LAN with range extender. Then as I discussed with the chapter 3, we have here also the physical layer. We have the layers here, the source node as the application, presentation, session, transport, network, data link. Physical, then it is converted the data from, we have the application data, the data itself with header, the trailer that will be transferred with bits, and from the will be come to physical, data link, network, transport, session, presentation, application through the destination node, and that is what we call encapsulation and the encapsulation. Then the physical layer media, we have the three types of layer media, or the media: the copper cable, which electrical signals; fiber optic cable, which is the light pulse; and the wireless as the microwave signals. So our functions with our bits conversation: 0 from 1 and 0, we have 0 1 0 1 0 1. Then it is called the Manchester encoding. We have what we call the modulating wave. It is called first it is called the frequency modulation. The first, we have the modulating wave, then the carrier signal, it equals into FM signals, and the amplitude modulation, or the AM, the modulating wave plus the carrier signal, or the AM signal. Then our bandwidth known as the limit of a data transferring or data connection. Then we have the unit of bandwidth here, the abbreviation and the equivalence, or is short for conversion from bits, kilobits, megabits, gigabits to terabits. Then our throughput, also the throughput. Then the types of physical media, we have the SHDSL interface, we have management ports, as well as the gigabit internet interfaces, the fast Ethernet switch ports, and the USB type A connector. Then we have characteristics here of copper cabling, differences of pure signal, uh, differences of pure digital signal, the interference signal, the digital signal with interference, and what the computer reads. And the copper media, we have three types of copper media. We have the unshielded twisted pair, or the UTP cable. We have shielded twisted pair, STP cable, and the coaxial cable. And the difference of the UTP unshielded and the STP the shielded, it is more cost using shielded twisted pair, because it is protected, it is more giving cost or more having big cost than the unshielded twisted pair that is usual used. Then we have the coaxial cable, particularly used with the televisions at home, transferring signal. Then at the unshielded twisted pair cable, we have parts of it. We have the outer jacket, protect the copper wire from physical damage. We have the twisted pair, protects the signal from interference. Then we have the colored plastic insulation, electrically isolates wire from each other and identifies each pair. So by connecting the unshielded twisted pair, it is important to connect the proper color coding in order to make it properly work. Because if it might be happen that you're mistakenly connect two different colors of cables, it will not be usable. Then we have the shielded twisted pair cable that added from the shielded, it is added by the braided or foil shield in order to make it more secure or make it more durable. A jacket, foil shields, twisted pair added by braided or foil shields. Then we have the coaxial cable. We have its outer jacket, the braided copper shielding, the plastic insulation, and the copper conductor. It is composed of 4 parts. So, as well as the coaxial connectors, you have here the what we call the B and C, the N type and the F type. Then the properties of UTP cabling. UTP cabling standards. We have category 3 cable UTP, used for voice communication, most often used for phone lines. Then we have category 5 and 5E cable UTP, used for data transmission. Cat 5 supports 100 MBs and can support 1000 MBs, but it is not recommended. Cat 5e supports 1000 MBs as well. Category 6 cable UTP, used for data transmission. An added separator is between each pair of wires, allowing it on function another higher speed function on higher speed. Then we have what we call the UTP connectors. We have the RJ45 and the UTP plugs and the RJ45 UTP sockets. They are the UTP plugs are used to connect with the UTP sockets, particularly with the devices used by the device. And as description, we have bad connectors. Wires are exposed, untwisted, and not entirely covered by the shield. Then the good connector wires are untwisted to the extent necessary to each connector. Then we have types of UTP cable. We have the T568A and the T568B. The T568A, it is transferring of color here, or swapping of colors happen. From the T568A, the green color is in the left side, corresponds with the number 1 and 2. Then at the other side, other corner, we have the T568B UTP cable that the green is in the middle, holding the number 3 and 6 on its pair. Then Ethernet crossover, one end T568A, other end is T568B. The collision or the using of those two by these both ends. Then we have the rollover or the Cisco Proprietary connects a workstation serial port to a router console port using a adapter. Then we have here the testing UTP cables. We have the testing parameters. We have wire map, cable length, signal loss due to attenuation, fiber media cable design, the jacket as the protects the fiber. The core is the light transmission element and center of the optical fiber. The copper is used to help shield the core and cladding from damage. Cladding made from slightly different chemicals than used to create the core. Strengthening material surrounds the buffer, prevents the fiber cable from being stretched when it's being pulled. We have the types of fiber media. We have the single mode and the multi-mode. The two of us are different with the sizes of the glass core, the glass cladding, and the coating. Network fiber connectors. We have the ST connectors, SC connectors, LC connectors, duplex multi-mode LC connectors. Testing fiber cables. We use optical time domain reflectometer or OTDR. Then here we have the comparison. We have the fiber versus copper. And the bandwidth, as we all know that the fiber optic is now being used in our era or our years because it is more strong with the signal or internet connection because of its connectivity by fiber optic cable, and it is more popular with the most popular service providers in the Philippines. It is used. We have the properties of wireless media. We have types of wireless media as Wi-Fi, Bluetooth, and the Wi-Fi Max. We have the wireless LAN, data link layer protocol, data link layer from the source to destination. And that's all. Thank you. Hope you like the video. Subscribe.